Here I'm going to introduce the topic of factorial ANOVAs. In order to do that, I want to contrast it with the kind of ANOVA that we've already started talking about, which is the simple or one-way ANOVA design. In a simple ANOVA, there's only one independent variable. For example, in this particular situation here, we might ask, does the method of communication impact how emotionally close you feel to the other person? So the person you're talking to, you might be talking to them in person, or over Skype, or over phone, or via text. And then you might rate your emotional closeness to that person on a 10-point scale. And perhaps if you were in person, you might rate them, rate feeling much closer to them than you would, say, if you were talking over the phone. I don't know if these trends would match up with reality, if you'd feel closer, over text than you would over the phone or whatever. But that's irrelevant to the issue at hand. This right here is an example of a study in which you have one dependent variable, emotional closeness, and one independent variable, which is the method of communication. But it has 4 levels. In person, Skype, phone, text, those are different methods of communication. So you've got one IV with 4 levels, and one DV, and you might be asking the question, are there any differences between any of the conditions? That's what we just finished doing in the one-way ANOVA. We wanted to know, are there mean differences across the different types of conditions that existed within our independent variable? If there are differences across these, like if 9 was statistically significantly different from 5, then we would say there's a main effect. There is a significant difference, but we would call it a main effect of this independent variable. There are differences somewhere. And of course, as you know, we would run some post-hoc tests now to see where the differences lie, which conditions are different from which other conditions. You can do 2 types of one-way ANOVAs. You can do a between subjects or a within subjects. Between subjects ANOVAs are those where different people are in each of the different groups. So you might have like 10 people recruited to talk to another person in person. You might recruit another 10 people, different 10 people, to talk to somebody over Skype, another different 10 people to talk to them over the phone. But if you did it within subjects, then you would take the same 10 people and you would make them do each of the 4 conditions. So you would say, okay, today we're going to have you talk to your friend in person, tomorrow we're going to have you talk to them over text, the next day over Skype, the next day over phone. And we'd counterbalance that across people so that everybody was doing these conditions in a different order, but everybody would do all of the conditions, and you'd compare how close they felt when they were in this versus that versus this versus that, and see which ones people felt closest to. So again, this right here is the same as what we sometimes call a repeated measures. So within subjects or repeated measures, either way it's the same thing. Now, a factorial ANOVA is important because in real life, independent variables rarely have an isolated effect on dependent variables. It's not like the emotional closeness you feel with somebody is only going to depend on the method that you use to communicate with them, whether that's like over the phone or in person. It will also depend on like how well you click with that person, like your personality type. It will also depend on your mood of the day. It will also depend on whether they're of your same or opposite gender. It will depend on whether they're attractive or not. I mean, there's all kinds of things that will dictate whether you feel emotionally close to another person. In one example, we might say, for instance, do you think that therapy techniques always work? Or are there other things that will make therapy more likely to be effective when those conditions are present? So an example of this, the most salient example when you think about therapy should be the therapeutic alliance. If therapy works when the therapeutic alliance is strong but doesn't work at other times, then it would be inaccurate to lump all therapy together and evaluate it without considering the alliance. So I'll show you a graph in a second to illustrate what I mean, but a therapeutic alliance is just like when a therapist and a client meet together and they both feel like they're on the same page, like things are clicking, like the client knows that the therapist is on their side and considers them with unconditional positive regard. They like each other, they're making progress together, they feel like it's just clicking. It's hard to say exactly, what that means in concrete terms, but the therapeutic alliance is that relationship between them that feels like they're allied, they're together on the same page and working together to make this work. Now again, if the therapeutic alliance is strong, then you would expect that the therapy is going to work. And in reality, this is the most important thing you can have in a therapy-client relationship. If this is there, it kind of doesn't matter whether you use like cognitive behavioral therapy or just cognitive therapy or behavior therapy or like rapid eye movement desensitization therapy or just whatever kind of therapy you're going to use. It doesn't really matter so much as that you have a therapeutic alliance. So you would expect that therapy should work really well when therapeutic alliance is strong, but it might not work that well at other times if you don't have that good of a relationship with your therapist. So if that's the case, then we shouldn't lump everybody together and just say therapy is modestly effective, which is what this would look like. If you had before treatment measurements and after treatment measurements, and you wanted to measure mental health, you might show that overall, after treatment, things have gotten better. Mental health has increased a little. But this might not reflect reality. If you split this up into two different categories, and you considered those two categories as the people who had a strong therapeutic alliance and the people who had a weak therapeutic alliance, then you'd all of a sudden see this. The blue line might represent those with a weak therapeutic alliance. So before treatment, they were the same as after treatment. That means there was no change in their mental health. It didn't work. Why? Because they didn't have a good relationship with their therapist. But the green line might represent those people who had a good relationship with their therapist, and they got much better before treatment. So if we go back to the average, we would take the green point and the blue point right here and average them together, and it would still be right there. But if we took the green point here and the blue point here and average them together, it'd be somewhere in the middle, right here. So you can see that this would kind of wash out the effect of therapy, and we would make it look like it was only modestly effective for everybody, but in reality, it was very effective for some people and not at all effective for other people. So in a situation like this, you're using a factorial ANOVA to get at the truth of the matter by looking at more than one independent variable at the same time. You might be looking, like in this case, before versus after as one independent variable, and therapeutic alliance, weak versus strong, is another independent variable. So you'll look at both at the same time. So what is a factorial ANOVA? An independent variable is also known as a factor, and so when we say factorial, it means an ANOVA with more than one factor, with more than one IV. So factorial ANOVA is an ANOVA that has more than one independent variable, and we can say how many there are by describing an ANOVA like one-way, two-way, three-way. So if it's a one-way ANOVA, then that's a simple ANOVA. That's what we just learned about in our most recent statistic. That's where we have only one independent variable. So that's not a factorial ANOVA. But if you have two independent variables, then you call it a two-way. And if it's three independent variables, you call it a three-way. So you just call it however many ways there are, depending on how many IVs there are. And you can also have independent, meaning between subjects variables, or repeated measures variables, or mixed ANOVAs. A mixed ANOVA is where you have some between subjects and some within subjects, some independent and some repeated. So you have to consider what kind of independent variables do you have. Do you have only independent variables? Sorry, that's a weird way of saying it, but only between subjects independent variables, or do you have repeated measures or within subjects independent variables, or do you have some of each, and then you call it a mixed. So we can also specify a factorial study by how many levels each IV has. So I'm going to show you an example of drawing this out using kind of like little tables, little boxes, and each cell will represent one condition in each of these things. So in the most simple kind of factorial ANOVA, you might have a 2 by 2. What that means is you have two independent variables, and each of them has 2 levels. So this right here is the first independent variable. That'd be like the therapeutic alliance, weak versus strong. That's the 2 levels, weak versus strong. And this level, this number right here would represent that it's the first independent variable. And the other independent variable might be before and after treatment. So that would be the independent variable would be called time, and it would have 2 levels also, before and after. So you would draw out these 4 conditions here by saying, like, this cell right here is before treatment and a strong therapeutic alliance. This is after treatment and a strong therapeutic alliance. This is before treatment and a weak therapeutic alliance right here, and after treatment, weak therapeutic alliance right here. So you can see that you've got 4 different conditions when you have 2 independent variables. You could have 2 independent variables but add on another condition. So you could have like still before and after, but you could have like a weak, so like a strong therapeutic alliance, a moderate one, and a weak one. So that would give you 3 levels, but still only 2 independent variables. The first independent variable, strength of alliance, and the second one would be time. So you can see that then you'd have like strong, the 3 levels would be strong, moderate, weak. Strong, moderate, weak. And you'd make that across both before and after. Okay, then you could also have, like, say, 2 independent variables, but each one might have more levels. So you could have 3 levels here and 4 levels here. This might be like, let's kind of switch gears because this is getting a little convoluted with a therapy example. But you could use, like, you want to know how fast are people going on the freeway when they drive 4 different kinds of cars and 3 different colors. So it might be like a red car, a yellow car, and a white car. And you might have like trucks, sedans, sports coupes, and shoot, what's another kind of car? Something else, I don't know. Anyway, so you could have 4 different kinds of cars, 3 different colors, and you could see how fast are people driving on the freeway when they drive different combinations of the colors and types of cars. You could even go beyond 2 independent variables. You could have 3 independent variables, and you could have, like, so that's to say this is the first independent variable, it has 3 levels. The second independent variable, it has 2 levels. And the third independent variable, it has 2 levels also. And you would represent that like this, 3 by 2 by 2. So you've got 3 here, you've got 2 here, and you've got 2 deep. So each of these cells, each of these cubes would represent 1 condition. So you'd have like just, one condition here being this cell, 1 being this cell, 1 here, 1 here, 1 here, 1 here, 1 in the back. So you could see this right here is a total of 6 conditions. 12 conditions. There's 6 on the top layer and 6 more on the bottom layer for a total of 12 conditions. You could even go beyond that. Like this is illustrating 3 independent variables. You could have 4 independent variables, like 2 by 2 by 2 by 2. And that might be like if you had a therapeutic alliance that was weak versus strong, and you had before therapy versus after therapy, and you compared men versus women, and you compared the wealthy people versus the poor people, then you would have, like, in each of these major groups here, you'd have 8 conditions, and because you have 8 conditions for the wealthy and 8 conditions for the poor, that's a total of 16 conditions, because you've got 4 different independent variables, and each independent variable has 2 levels. And statistically, you could even do more. You could do like 5 or 6 independent variables, but it becomes beyond our mortal minds to understand the interactions between multiple independent variables, and so it's probably best not to go beyond, like, much beyond that. We're going to go through some practice exercises now, and for each of the following, I need us to think of the answer to some questions. How many factors were used? How many levels were in each factor? And was this kind of like a independent ANOVA, or repeated measures, or a mixed? And so I'm going to guide us through this process. After we read each of these examples, I want you to pause your video, think about the answers to these different questions, and then I'll explain the answers. So the first one, a researcher is interested in whether dogs or cats make people happier. Each participant is given a dog, cat, or no animal to care for over the span of a week. The researcher also measures whether participants considers themselves to be a cat person or a dog person. At the end of the week, he administers the Oxford Happiness Scale. So we need to now consider how many factors were used, in other words, how many independent variables were used. Then, of the independent variables there, how many levels were there in each factor? And are there any between subjects independent variables? What about repeated measures? And so after we do all that, we want to be able to say, what type of ANOVA is this? This is like a blank by blank, or blank by blank by blank by blank, however many there are, and just say the number of levels, and then we say whether it's a totally between subjects or within subjects or mixed. So I want you to be able to answer these 4 questions. Go ahead and pause and play again when you're ready. So the answer here to how many factors were used, if we look back over this again, should be 2, because each participant was given a kind of animal, and the researcher also cared about whether they thought of themselves to be a type of person, cat or dog person. Those are the 2 independent variables. How many levels are in each of those factors? Well, in the first factor, you see that people were given either a dog, a cat, or no animal. So that's 3 levels, 3 different kinds of things. Then, in the other independent variable, we asked each person to say whether they were a cat person or a dog person. That's 2 levels. So, I'm going to skip number 3 and just come here for a second and say this is a 3 by 2 ANOVA. 3 by 2. 3 levels here, dog, cat, no animal. And 2 levels, cat person, dog person. 3 by 2. All right, the dependent variable is the Oxford Happiness Scale. He wants to see whether the people are happier if they have a dog or a cat, based on whether they are a dog person or a cat person. Now, are there any between subjects variables? Well, we know that if we look at the type of animal that was given, people weren't given a dog and then also a cat and then also no animal. They were only given either a dog or a cat or no animal. So that's a between subjects variable. They were only in one condition. They were not repeated across multiple conditions. What about this one? Were some people both cat people and dog people? No, it didn't give that option. Though some people could probably say they were cat people and dog people, that was not an option in this study. He just wanted, the researcher just wanted people to identify themselves as either a cat person or a dog person. So you were either one or the other, meaning this is again a between subjects independent variable. And therefore we can say because both of the factors were between subjects and neither one was repeated, then we would call this a 3 by 2 between subjects ANOVA. Alright, here's another example. Dr. Pendergrass wants to see whether time of year influences how people perceive temperatures. She recruits a cluster of participants in the middle of each season, the spring, summer, fall, and winter. She places each person in a room that is maintained at either 65 or 75 degrees and has them work on one of 2 tasks, either a boring task or an engaging one. After 10 minutes on the task, she gives them a survey that says, "How's the temperature in here? Circle a number from 1 to 10 where 1 is far too cold and 10 is far too hot." So I want you to identify how many factors were used, how many levels in those factors, and were there any between subjects, were there any repeated measures, and so how would we characterize this ANOVA? Go ahead and pause your video and play when you're ready. So the answer to the first one is that there were 3 factors. We know that she's recruiting people during different seasons, and she's placing them in different temperatured rooms, and she's giving them different kinds of tasks. Those are the 3 factors. How many levels were in each one? Well, the first one had 4 because she was recruiting them at different times of year, spring, summer, fall, and winter. The second one had 2 because she had 2 different temperatures, 65 and 75. And the third one also had 2 because it was a boring task or an engaging task. So it was a 4 by 2 by 2. Are they between subjects or repeated measures? Well, the first one we know was not repeated because she was taking people and putting them in one of the four, not all of the four. Then the second one, she was also doing between subjects because she was putting them either in a cold room or in a warm room, 65 or 75, not both. And the third one was she was giving them one of two tasks. She was not giving them both. She was saying either boring or engaging. So all of these are between subjects variables. None of them are repeated. Thus, this is a three-way ANOVA that we would call a 4x2x2 between subjects ANOVA. Here's another example. Juanita intends to study the relationships between race and family size. She stands outside various grocery stores in town and asks people to answer a 2-question survey. The first item asks their race. On this kind of item, it says white, Hispanic, black, Native American, Asian, other. The other question asks how many children they have. So, how many factors were used? How many levels in each factor? Are they between subjects or repeated measures? And what type of ANOVA is this? So the answer to the first one is a little tricky here because she's actually only given them one independent variable. The dependent variable is how many children they have. So that's not actually a factor. That's a DV. Thus, this is a one-factor ANOVA. How many levels were in that factor? White, Hispanic, black, Native American, Asian, other, 6 levels. Are they between subjects? Well, this right here, you can't be, well, that's a little tricky, huh? Because you could be multiple, but probably if you were mixed race, then you'd have to identify under other in this particular situation. But the point is, you're not forced to be white and then counterbalanced in a random order, forced to become Hispanic and then forced to become black and then forced to become Native American. You're in one of these groups, so that's a between subjects independent variable. And finally, what type of ANOVA is this? Well, we would call this a one-way ANOVA because there's one independent variable, and thus we couldn't characterize it as a blank by blank because there's only one IV. But we would call it a between subjects ANOVA. So we would call this a one-way between subjects ANOVA. Here's another example. A professor wants to know whether people are more likely to carpool in different types of cities. He surveys 1% of the population in each of the following: Seattle, a large city; Yakima, a medium city; and Ellensburg, a small city. He also groups people according to the hours they typically work. If they work daytime hours, anytime between 7 a.m. and 8 p.m., versus odd hours, sometime outside of that. And whether they have any friends at work they would feel comfortable traveling with, yes or no. He asks how many days per week respondents share a ride to work. So, answer these questions and push play when you're ready. So there are 3 factors here. The first one is the size of the city you live in. The second one is the hours that you're working. And the third one is whether you have friends you're comfortable with. How many levels are in each of those factors? Well, there's 3 different sizes of city: large, medium, and small. There are 2 levels in your working hours, either daytime or odd. And there's 2 levels of whether you have friends at work that you feel comfortable commuting with, yes and no. So you would call this a 3x2x2. It's a 3-way ANOVA because there's 3 factors. There's 3 levels in the first, 2 levels in the second, 2 levels in the third. And now we can consider, are they between or repeated? Well, the first one is size of city. People aren't living in both Seattle and Yakima and Ellensburg. They're not being forced to move around. They live in one or the other or the other. They're not working both daytime and odd hours. They're not forced to swap between them for the purpose of the study. So again, between subjects there. And they either do or don't have friends they can commute with. It's not that they're forced to give up their friends halfway through the study or forced to make new friends halfway through the study. They just either do or they don't. So again, between subjects. So we could say that this is a 3x2x2 between subjects ANOVA. Here's another example. This study sought to determine if a woman's appearance influences perceptions of her ability to perform a job. Undergraduates rated a photograph of a woman that was either dressed professionally or sexually. The undergrads were also told that the woman was applying to be either an office assistant or a CEO. Participants rated the photo along several dimensions, such as grade point average, organizational skills, leadership, dependability, and intelligence, and all of these measures were combined into one competence measure. The researchers found that a sexually dressed CEO was perceived as the least competent. Now, the reason I've given a finding here is because this is actually a real study. This is actually the phrasing of an abstract that comes from a legitimate study that was published. I want you to go ahead and try and identify how many factors, how many levels, and whether they're between or within so that you can characterize the whole ANOVA. So, first we can see that the woman was dressed either professionally or sexually, and she was applying to be either an office assistant or a CEO, and the other variable that they were rating here, all these things that combine together into competence, that is the dependent variable. So there's really only two factors. How many levels are in each of those factors? 2 in each. Professionally or sexually, office assistant or CEO. Are they between or repeated? Well, the undergraduates were only asked to rate one photo, and they were told information about that person. In the photo, she was either dressed professionally or sexually. They weren't shown multiple pictures of both kinds. They were just showed one photo, and each person rated that photo. They were also told information about her, that she was either an office assistant or a CEO, but they were not given multiple photos and told different things. So both of those, again, are between subjects. Thus, we could say this is two-way independent or two-way between subjects ANOVA. We could say this is 2 by 2 between subjects ANOVA. There's different ways of characterizing it there. Alright, this study sought to determine whether a third party could discern romantic interest between two strangers. To test this, male and female observers watched video clips of speed dating situations to determine the individual speed dater's level of romantic interest toward the speed dating partner. Participants observed clips of different lengths, 10 versus 30 seconds, and from different parts of the speed date, beginning, middle, and end. Each participant rated 1 long and 3 short video clips. The researchers also coded for participants' gender, male or female, and relationship status, single or in a relationship. Results indicated that participants were able to discern romantic interest at above chance levels. Length of clip did not influence accuracy, although the part of the speed date did. So again, this is a real study, that's why it's so convoluted, but when you see things like this in an actual abstract, you need to be able to discern how many factors there were, how many levels, and what kind of ANOVA this is. So I'm going to pause, and or you should pause, and then proceed when you're ready. So the number of factors here is 4. There are 4 independent variables. They are the length of clip, the part of the speed date, the gender of the participant, and the relationship status of the participant. The number of levels for each of those conditions is 2 in the clip length, 10 versus 30, 3 in the part of the speed date, beginning, middle, end, 2 in the case of participants' gender, male and female, and relationship status is 2, single or in a relationship. So this could be characterized as a 2 by 3 by 2 by 2. Now, are they between subjects or repeated measures? Well, the information about the actual participant themselves is between subjects. People were either male or female. They were not randomly assigned to be one or the other and then swap halfway through the experiment. They were either in a relationship or they weren't. They were not forced to be the opposite of what they were halfway through the study. They were either one or the other. However, people were showed multiple videos, and each of the videos was a different length, 10 versus 30, and they had different parts of the speed date, beginning, middle, and end. So those were both repeated measures. So people saw, as you see here, each participant rated 1 long and 3 short video clips. So they would have seen 1 30-second clip and 3 10-second clips, and those would probably be from different parts of the speed date. So some of those videos might be from the beginning, some from the middle, some from the end. And thus, you'd find that both of those two measures were repeated. Though that latter one, if you didn't get that correct, the issue of whether the part of the speed date was repeated or between, it's unclear in this abstract. I'm making an assumption, but you'd have to actually go to the study itself in order to determine for sure. So what kind of ANOVA is this? Well, we would call this a 2x3 by 2x2. In other words, it's a 4-way mixed ANOVA, because this has some between subjects variables and some repeated measures variables. Okay, this is my last example. To evaluate whether imagined ostracism can be a painful experience for individuals, researchers recruited one real participant and put him or her in a room with 2 Confederates. And participants were told to interact with the other participants, who really were Confederates, via texting until they were directed to stop. The Confederates asked a few questions like, "Do you exercise?" and then asked the participants if they smoke. For half, the Confederates created an in-group effect by telling the participants they did the same. Like, for instance, if you were in the study and you didn't smoke, then they would ask you that question, and you would say no, and they would say, "Yeah, me neither." Or if you're the participant and you did smoke, and you said, "Yeah, I smoke," they would say, "Yeah, me too." But for the other half, they created an out-group effect by telling the participants that they did the opposite. So if you said, "Yeah, I smoke," they'd be like, "Oh, I don't. That's gross." Then the Confederates either kept responding or stopped responding to the participants' text messages after the initial conversation. So they asked those few questions, and then sometimes they kept texting, and sometimes they stopped responding. After the study, blind coders analyzed the content of the text messages. So people in the study were told to keep texting, and so they would keep writing out stuff. And after the study, coders were looking at what kinds of things they were typing out, and you can see that they found participants made more provoking types of comments when ostracized. For example, "Are you people not speaking to me? I am being oppressed." And "How come no one is messaging me?" A post-manipulation survey showed that those participants who were ostracized also reported a worse mood, a lower sense of belonging and control, and lower self-esteem. Whether the participants perceived themselves to be part of an in-group or out-group did not influence the ostracism effect. So, just to kind of debrief, make sure we all understand what's going on before I ask these 4 questions, I'm going to say that this post-manipulation survey means after they were done, they gave the participants multiple dependent variables. They tried to assess what was the impact of all this stuff going on up here on their mood and their sense of belonging and their sense of self-control and their self-esteem. So they were looking at multiple different kinds of outcome measures. So those are not relevant to these questions up here because those are DVs, not IVs. What I want you to figure out now is how many factors were used and how many levels were in each of those factors in this description up above. So the answer to the first question is there were 2 factors. They were in-group versus out-group and kept texting versus stopped texting. How many levels in each factor? Well, there was 2. Again, in-group versus out-group and continued versus stopped. So this is a 2x2 ANOVA. But are they between subjects or repeated measures? Well, both of those are between subjects variables because people were either put into the in-group or made to be in the out-group because of the answer to the smoking question. And people were either continued to talk to or they weren't. So neither of those 2 conditions was repeated. They were just between subjects. So this would be called then a 2-way, 2x2 between subjects ANOVA. And as you see here, the finding is that participants, it didn't matter whether they were, whether the answer to the smoking question didn't matter. If they stopped texting you, then you felt frustrated whether or not you were made to feel like there might be a reason for that. Like, oh, we don't smoke, but you do smoke, or the opposite. So I just want to stop there and kind of just, now you have a big picture idea of what it is to do a factorial ANOVA. I'm going to tomorrow I'm going to walk through a little bit more of the kind of math that's going on and what it looks like to actually compute. I'm not actually going to walk through any of the formulas or the math. What I want to do is more conceptually, statistically walk through what's going on, because what we've done so far is mostly research methods as opposed to statistics. So tomorrow I'm going to kind of take a look at the Factorial ANOVA from a statistical framework.